After finding acceleration, we need to find the normal force. We will use the formula normal force is equal to mass times acceleration. Substitute the given for mass and acceleration. For mass, we will substitute 180 kilograms, and for acceleration, we will substitute 11 meters per second squared. Multiply 180 kilograms and 11 meters per second, and we will have the answer 1,980 newtons, which is our normal force.
The balikbayan box is lying on the surface with a normal force of magnitude 83 and the coefficient of static friction between the surface and the box is 9.75. What is the maximum static frictional force? So when we say static friction, it is a force that keeps an object at rest. Static friction definition can be written as the friction experienced when individuals tries to move a stationary object on a surface without actually triggering any relative motion between the body and the surface which it is on. So first, let us draw a sketch of the problem. This is the balikbayan box lying on the surface with a normal force of magnitude 83, and the static friction between the surface and the box is 9.75. So what is asked in the problem? It is the maximum static frictional force. The given are the normal force of magnitude, which is 83, and the coefficient of static friction between the surface and the box is 9.75. Now, here is the free body diagram of the problem. The balikbayan box is represented by a dot, and the forces are represented by vectors. We have here an arrow for the normal force, for the gravity or weight of the balikbayan box, and the static friction between the surface. To get the maximum static frictional force, the formula will be maximum friction equals the coefficient of static friction times the normal force of magnitude